Alright guys, we're going to look at one more section today, and we're going to skip over 4.6 for now. We may come back to it, we'll see, but we're going to look at simplifying variable expressions involving adding our integers. So we're going to just call it simplifying variable expressions. Okay, so we're going to do some quick definitions to remind ourselves. When we have an expression, remember, it does not have an equal sign. So I could write 3x, and that would be an expression. If I'm going to write an equation always has an equal sign, so it would be like 3x equals 3. And then I can reduce it and find out that x equals 1. But in this one, I can't figure out what it means. It just kind of stays the same, right? All right, we're going to be looking at variables again. Remember, variables are when we use numbers to represent a whole set of possible numbers. And a variable expression is kind of the combination of all of these things. Now we're going to be talking about two more words in this case. We're going to be simplifying like terms. And what like terms means is when we have two sets of variable expressions, we can only add them together if they are like terms. Let me show you what I mean. If I have 5x plus 2x, I can add those together because it's like saying 5 oranges plus 2 oranges is clearly 7 oranges. But if I have something, so this one is a check, I can add those together. But if I have something that says 5x plus 2y, I can't add them together because they're not like terms. So as much as I can simplify this, it's already simplified. It just ends up with 5x plus 2y. Because this is 5 oranges plus 2 hamsters, and I can't add them together because they're not similar terms. So I have to keep them separate. So we're going to see a lot of that in the problems on this, and making sure that we add things together that are like terms and that are similar. So when we are adding like terms, one of the key things we have to look for is the coefficient. I want to spell this right. And the coefficient part of a variable expression is the number in front. So if I write 5x, this 5 right here is our coefficient. And it tells us how many times that we're going to be multiplying that x by. Because remember, there's always that little implied multiply in between, right? But we don't have to write it because in math we use multiplication a lot, more than anything else. And we don't really write it as often as we need to, because mathematicians are lazy and they're saving space. So when we are doing our like term addition, we always need to make sure that we have like terms to add. Let me show you some examples. So they're also of course going to throw in our negative and positive numbers with using our number line. So there's sometimes going to be multiple problems in one. Let's take a look at a quick, because I won't use that color, a quick example using example 1. We're going to add this together. We're going to say we have 12x minus 3x plus 2y. All right, now if I'm going to simplify this down, I can do 12x minus 3x, but I can't do anything with my 2y. So to simplify this, all I would do is I was write 9x plus 2y, and I'm done. My variable expression is simplified. There's literally nothing else I can do without knowing the value of x and without knowing the value of y, which I don't know, so I'm stuck here, and this is as far as I can go. Okay? Let's look at example 2. Example 2 is going to say this. We have negative 8x plus a negative 5x. All right, well, this should look familiar to some of the problems that we did before. Now, can I combine them? Do they have like terms? Yes, I can. They're both related to x, so I'm good to go. But I need to remember which direction I'm going. This is negative, and here I'm also subtracting, because if I add a negative, that's the same as subtracting, so I'm going to be going left. So if I drew my number line, and I had my negative 8, I'll be moving this direction. So I'm going to add 8 negative this direction. I'm going to add 5 in this direction, take away. So 8 and 5 is going to end me up with negative 13x. And my x stays the same, and it kind of joins along. And this is simplified for what I've done so far. Okay? Oops. Oh no, I was mostly in line with that one. Okay, I'll make sure to move my page up so that I have some more space. Let's look at example 3. All right. In this case, we're going to look at, I'm going to find a little bit of a trickier one for us. Okay, we're going to take negative 6y plus 2y plus negative 3y. All right, so in this case, again, they are trying to throw me off by thinking about that number line in the direction that I need to go. So if I start at negative 6, and now, first I need to check, do I have like terms? Yeah, I can add all these together because they're all y. It's fine. So I have negative 6. I'm going to add 2. So I'm going to go 2 this direction. Puts me at, I'll put a negative 4. Then I need to subtract 3 more in this direction. So I'm going to move 3. So 3 direction this way would be 7. So I'm going to end at negative 7. So I have negative 7y. And I can use my number line to kind of jump around and use that, okay? So now I'm good. I have all of my like terms simplified. All right? Make sure that they are the same letters first. It looks like most of the problems that you have will do that. One more little trick that they will do is this. If I look at example 4, they may say 3x plus 6x plus 5. Now, I need to make sure that I'm doing my like terms here. And these two I can add because they're both being multiplied by x. But this 5, I can't add it into the rest of my expression here. So all I can do to simplify this is add these two together into 9x plus 5, because it's not a like term. It's like I have, again, my 9 oranges plus 5 of something else that isn't multiplied by anything, and it just might be important in the equation later. Okay, good luck on remembering the positives and the negatives in the direction, and please check your answers after you do them. Good luck.